The electrochemical signal is retrieved by the dendrites from the neighboring neurons and is attached to the soma or the cell body, which contains the nucleus of the neuron. The action potential moves from the soma to the axon, which is covered by the myelin sheath, a tissue that is able to speed up the action potential propagated. The action potential finally reaches the axon terminals, where the neurotransmitters are released through the synapse, which is the gap separating the neuron from the receptor sites on dendrites of another neuron. The all or nothing principle states that the neuron will fire or will not. In this demonstration, the cell is at negative 70 millivolts, or resting membrane potential, when suddenly it reaches negative 55 millivolts, or the threshold. This causes an excitatory cell, propagating the action potential. In this case, that's Frank. Frank moves down the axon and depolarizes the cell, causing an influx of sodium ions into the cell, which makes it more positive. As Frank moves further down the axon, the sodium channels eventually close, and the potassium channels open, which causes an efflux of potassium ions, or repolarization. This makes the cell go back to being more negative. The cell goes through the refractory period, which causes the cell to go below the resting membrane potential of negative 70 millivolts, since potassium channels close more slowly than sodium channels. As Frank flows toward the axon terminal, he releases the neurotransmitters. Some make it to the receptor sites on the postsynaptic membrane of various other neural cells, while others do not and are taken back up by the neuron in a process known as the reuptake process.